There we go. Good morning, chat. Good morning. How's everyone doing this morning? Or wherever you're at. How's your day, afternoon, evening? Oh, Alcius, yeah, no. Yeah, I I felt so silly when I went into their chat this morning and I went or like last time and I went, "Hey, this is what I'm doing." They're like, "Oh, what about trim?" And I was like, "Oh, that makes a lot of sense. We'll do that instead." So, a couple updates actually on the project. So I worked on it a little bit over the last couple of days. CD fast PDB. Oh, RM lsp.lua. I was editing files and this terminal was open, so like there's a lot of stuff in here. Oh, so I'm gonna clean that up first. RM perf dot star. Um, yeah, we were doing some flame graphs of it. Okay, so here's where things get a little fun. I had a thought the other day. So I said, okay, so here's the long and the short of it. I ran into a couple file formats, a couple versions of PDBs that are non-standard, and one of them is this 227L Druid, which is used by a couple molecular modelers to do some weird. They do a different model for how they model their force fields in proteins. So because of that, they have a weird thing where their files end at 7 or what is this 80 76 lines. So that doesn't meet our 80 line spec, and that's really interesting because uh, the way we were doing it before worked fine, right? Because we were doing this kind of read until delimiter, but it's kind of slow. The read until delimiter. I was benchmarking it against Rust, and it is a bit slow. So we're gonna we're gonna try something a little different today. We're gonna try something out a little bit differently. Um, oh man. So let's see. So here was what I was thinking. First of all, we've expanded. Well, there's multiple versions of these now. So we have the buffered stream reader, the array list reader, which I found out that array lists are interesting because they don't under the hood they're just arrays, so they don't really like allocate the same way as like a true like malloc call, which we'll get to that in a second here. That's what this heap reader does. So this one is interesting, and we can run this to kind of show you how fast the performance difference is. We'll do I think other is the one where yeah, this is 1.2 spec, and this is why I really want to get this right. Okay. So okay, so we'll try it with the heap reader. Um, so even without optimizations, so we'll do 10,000 runs. And yeah, I know the prints are going to take up a little bit of time, but it's parsing it. Okay, not bad. So we're looking at 765,000 nanoseconds on average, or what is that, like 7 microseconds, zero point 0.7 microseconds. Um, yeah. So this is kind of the thought, right? As we do this, it gets a lot faster when you do some compiler optimizations to it. We're not going to do that right now, just because for the sake of this, we're gonna just to kind of show you what I was thinking about. So that's that one, right? we do it with the array list reader, did I change what it's called? Array list stream reader, which was the other one. Sorry, this has been going through it. Recent stream stream reader. And we do it again. It's quite a bit slower. Let's see. Yeah. So if you look, we're getting this like we run it with the array list in the stream until delimiter. It's much slower than if we just say, "Here's the bytes." 80 characters given to me, which is great. It works in the case where we match the spec, but there are other uses of PDBs where the last, few characters are not to spec. I haven't really figured out why that's the case yet. I haven't really dug into the Zig standard library as to why, but yeah, look, this is taking forever. It's going to be a lot longer. Yeah, it's like almost 10 times longer, which is kind of ridiculous when you think about it. Like, that really shouldn't take that much longer. It's a little bit different. I mean, it's, an array list allocation rather than just a static allocation or a heap allocation. But it is kind of an interesting idea, right? Like, why is it running this? Why is it so much slower? And I think it is just how we're allocating that memory. But then also, I think it has something to do with this reading, how we read this here. So we're basically reading from a reader and streaming it into a writer, and that's what we're doing here. But my thought was, what if instead of doing that, we do something like this? And this is a mess, so bear with me here. It still doesn't work quite yet. But the goal is, what if, so remember how before, and for those of you who are new here, this is kind of the thing that's kind of interesting about this. The line has a spec of like very specific bytes of like what goes where. And the thing is what I noticed was that most specs, these atom lines are useless if we don't have anything past, basically the only thing that is really cared about is up through this Z coordinate, right? Because at the end of the day, it's like the point of the PDB is to store the coordinates of the file. So my thought was, let's store up through Z. Let's store up through that Z coordinate, right? And then once we get to the Z coordinate, then we can conditionally parse till the end. And my thought is that we can parse it one byte at a time until we get to that new line character, and then we'll do it again. Now, I think that the array list is pretty fast, and since under the hood it's just like a slice or an array, we can just parse the array and then append on the end of it those last few bytes. And the thing is I think we should only need to do that one time, because generally speaking, every atom is in the same spec, right? They're all generally the same length. Now, that's in this case. I will admit that there are times where you open one of these files and there's a couple atom types are not the only types that can exist, and we'll pull that up and kind of take a look at that here shortly. Yeah, let's take a look. So the coordinate section, for anyone who's interested, no, not there. Model, main index, this one. For anyone who's interested, here's the spec that we can take a look at. So basically, the long and the short of it is, the biggest thing so this has a couple parts, right? So the coordinate section is the part that we're working on right now, and the coordinate section mainly we're working on the model. But the other one, the atom part, the other one that I've seen is the heat ATM, which is for non-polymer or other non-standard chemical coordinates, just water molecules. So a lot of times when we're working with some of these systems, you'll see that there's like, they're trying to put like a molecule in water or something like that. So you'll have that as well. So it's not exactly just the raw file. And so that's the thing I kind of ran into here, was that the spec applies to when we are just in like when we just are using the raw files from www.pdb, which is where the like repository of these files, and those are crystallographic files. But the PDB format has kind of been adjusted and adapted to be used by other fields for their purpose. Now, most of it is the same because the information is still valid, but they might not care about all of it. And so because of that, there's a couple things that happen. Number one, the missing components, so like this space 4, which is like a 10 bytes that are missing between 66 and 77, those might be used for other things. Same thing with this space here, and this space here, and this space here. But the one thing that I noticed that was pretty constant between all of them is that the X, Y, and Z coordinates are pretty much always there, because it's what matters the most between atoms. Right? It's what is most interesting about these is their coordinates, right? Because we're using this to define positions. So, my thought is, let's read up until Z. Like this. So we modify this. There's a lot of debug lines in here. We read into the large buffer of a size of 66, which is the large buffer is just a standard array. We read in 66 bytes. Then we deinitialize the buffer. Cool. Because we don't want to be leaking memory here. Or no, that's for the array list. Sorry, misspoke. So we read the large buffer. We're keeping track of the buffer length. We read it in. We read those 66 bytes, which is up to the coordinate. Then we individually read the bytes until we get to the end. Then we append the two together, and then boom, there we go. Now, here's where the problem arises. Writing a spec for each variant, assuming it's a small number, and then having the user choose which one to run against. So I thought about that. But the issue with that is, first of all, there's no spec that's defined for each one. Sometimes they are a little different. Also, I have other things about that. The other thing is that what if, every other program that works with these files, specifically the one that I'm kind of targeting and the one that I'm interested in like kind of working with, which is or trying to integrate into, because it's a Python and C++ based project, so we could integrate Zig code pretty easily into it, like grafting it in, and we'll talk about the Python wrapping piece of this eventually. Thanks to Loris, he was kind of looking at that the other day. I am interested in kind of doing that. It's a project called OpenMM, which does molecular simulation, specifically for GPUs, but there's one part, wrappers, Python. PDB file. This is how it reads in files. And this script, this Python file, supports that. So we need to be able to support it too, right? It shouldn't be on the user to support it. They just want to simulate their work. They just want to do their thing. We want to simulate it as well. We just want to work as is. Easier said than done for sure. So, yeah, we're gonna do basically. We're not doing this part. This is kind of the representation piece. We want to do. Oh man, where was it? There's this converts the PDB structure, which is kind of what actually does the parsing. So import, yeah, PDB structure. So PDB structure is what's responsible for doing parsing. Also, important to note, there's 3 other kinds of file formats that do this similar thing. So there's the PDBX file. I think there's the PDB ML. But yeah, this is basically what we're going to do. Is we need to be able to handle this. And so like this is kind of what I look at. And if you look, they're doing things like parsing, doing a slice of the string and doing that. And what's interesting is they do, this is for the crystal. The atom one is here. It does it in chunks, I believe. Let's see. If it's a model, if it's an N model, there's one that's like, if it's an atom, do the add atom. Go down here. Then it like parses out the parts. But yeah, that's kind of what it's doing. Is it's doing this like piecewise parsing of the file. And we don't want to do that. My goal is we slice as much of it as possible, iterate the back half of it. And then that would be kind of what we do. Now, this is likely to break, I admit that. But basically the goal is we should be able to, if we have any Zig people in the chat today, the one thing I'm trying to figure out is that if I have I want to be able to, this should work. Let's give it a shot. I'm looking at this and I don't remember what the bug was, so let's do that. There we go. Yep, it panics pretty quick. So basically we get to a point where there's an invalid free. When we de-init the buffer, I guess, how many runs does it make it through? Okay, okay. Actually, before we do this, let's make this a little easier to work on. Let's reduce the number of runs to like 2. Okay. And we can change this file to be something simpler. I think cat test. No, that's a different one. I think this is the one that's like shorter I made. Yes, okay. And yeah, we'll make all this like flag driven soon. I just have not had the I've been so focused on the rest of this that I haven't really worked on that. Okay, so this is the first line. Yeah, let's make this look prettier. So let's see. This is painful. Why am I scrolling around like this? So this would be a new line. Red first 66 bytes. And then this is going to do item length. Okay. Yeah, I probably need to add spaces there. Okay. So we read the first line. We read the second line. We get to the new line. We attempt to read the last line. I think is what it is. Yeah, see? 1 line, 2 line. We try to read the last one. It crashes, I think. Yep. Which I thought I was handling that. Oh no, I didn't. Let's see. So the heap reader, we did thing where we is that I port that up? So I think it's failing here. It may be less than the buffer length. If the number of bytes is read as 0, it means the end of stream. Is it because of like, does it break out of the loop? Like, okay, so it does break out of the loop, but it's an invalid free. So is that because I tried to free? Oh, okay. Defer, clear, and free. Buffer? No. Is it buff dot? Why is that the case? Invalid free. Why would I have an invalid free? It's on the allocator. So something with the allocator is weird. Wait, what if I just... I'm using the general purpose allocator. Do I need to do a clear and free? Or because if I remember correctly, the general purpose allocator should just drop it, right? Once out of scope. Yeah, let's try it. Hmm. But then yeah. Based on scope. Okay. Okay, so here's the thing though. Oh, general purpose allocator. But then it leaks eventually. So that's interesting. So why is this the case? So here's the thing that's interesting. Like this doesn't happen in this case. What are we doing? Defer, buffer, clear, and free. Yep. Which is the list. Yeah, I need to learn more about allocators too. That's kind of the thing I keep running into. Like I feel like there's more I should know here, and I just don't. Yeah, we don't need to free that. That'll just fall out of scope. I guess we could probably move. I don't want to move the buffer into the while loop because I don't want to reallocate a new buffer every time. I want to reuse the same buffer and just overwrite it. Also, we're doing like a clear of the capacity. Yeah, yeah. The allocators are they're the coolest part about, or not the cool. There's a lot of cool things about Zig, but the allocators are one of them. And I'm just like I sometimes I just don't know what I'm running into here. Atom set DNet. let's see. So where is it leaking? I'm guessing it's up here. Yeah, same thing. Try stack reader. Allocated slice. Oh, I wonder. Let's try this. Rather than deferring it. Yeah, exactly. Yeah, that is the biggest superpower. Now, the other cool thing about Zig is that you get the I for me personally, I think the comp time stuff is very interesting. But yeah, the memory allocation stuff is like a whole thing. And I think it's an interesting thing to bring up too, because I think that a lot of modern programming languages don't call that out, right? I mean, like Rust does, but like Rust is like a very opinionated way of how you're going to manage your memory, right? You're going to use the borrow checker, and it will be your lord and savior, and that's what we're going to do. But I think that what's interesting is that you get additional pieces to that, right? So you get the added benefit of like, oh, I maybe I want to use an arena allocator. Maybe I wanted to do something else. If I wanted to do, if I wanted to build a garbage collector and do something like that, I could conceivably write an allocator that does some sort of garbage collection, right? And that's I think what is really interesting is that you can just plug in a yeah. In low level rush, you kind of need to commit to the one allocator. Yep. Yeah. Exactly. Exactly. I like the idea of this too, of like, maybe if I was on an embedded architecture, right? Then like like an Arduino or, something like that, maybe I have some sort of memory model that doesn't necessarily work in this context. I can write an allocator to match that memory model. And that's to me is the power of that, right? So for context, a lot of my background is embedded programming. So that kind of thought of like how do I manage that memory when it gets kind of weird is hard. Like minimizing those mallocs if you're using a malloc at all, um, in embedded programming. That kind of thought is like really what tickles my brain of like why I'm like, okay, this is something that's actually worth looking into, and this is something that's like really interesting. Huh. I thought what it might be is that the comp time is very cool. That plus the build system too feels like an evolution of like preprocessor substitution, which never felt good. 100%, 1,000%. Yes, preprocessor. And the other thing is like preprocessor stuff isn't very consistent, right? Like you can't guarantee its consistency. Where I feel like in Zig at least I can guarantee the consistency of comp time, right? Like I can guarantee that this is going to run on whatever, which is cool. Um, hmm. So there's something that we're missing here. Let's look at the general purpose allocator. General purpose allocator Zig. Okay, we'll actually also open this one. Not a big fan of C. I'm a big fan of C, not C++. Whenever I feel like Rust feels like C++, I learn more Zig. No, that's fair. That's fair. 100%. I'm the same way. So here's the thing. I wrote a lot of Rust. I have an upcoming project that I will probably be streaming a little bit of Rust in, just because the tooling in it is a lot better. LSP tooling for Rust is quite good. So I have a project I need to work on with that. I think Alcius was here for that. We were working a little bit on building our LSP in Rust, but um, yeah, large alloc, small alloc. I think it's probably because of how we're appending. Oh, you know what I bet it is? I bet what it is that when we... Okay, so let's keep this within best practice. We're gonna remove this, put this back up top. Oh man. Yeah, let's put that back up here. Okay, let's see. Okay. Is it clear retaining? No, that's actually the wrong one. Yeah, we want that one there. It's this one that we want up top. Defer. Okay. I think it might be how we're doing. No, okay. Yeah, there was a period of time where I was doing this weird append thing, where it was like I was actually modifying the underlying list rather than the actual array list itself. I think now we are. Okay, let's see. Let's see. Let's think about this, people. Let's think about this. But yeah, let's see. This is it just buff.dnet? I mean, that's what I was doing before. Let's try that, I think. Invalid free. Okay. Let's, am I destroying the wrong thing? Allocator.destroy? Sounds a little aggressive. I'm not heap allocating this, right? Yeah, let's clean that out. Let's get rid of that. Okay, and the thing is, we don't want to free atoms, which is good. We don't do that. That gets freed here. Hmm. So where is this coming from? Dangling pointers and segfaults. Let's see. Man, lots of people live today. Sitting like, I'm like, why is my phone buzzing? Okay. Heap arena allocator. Do I just do an just do an arena allocator? Call it a day. I feel like that's overkill because we're not allocating that much memory. We're just dinit and clear and free. Great question. Dinit releases all allocated memory and buff dot clear and free invalidates all element pointers. So I guess, but see, so that's what it does. It sets your capacity in your length to 0 and then removes the frees the slice, the underlying slice. And this just frees the slice. Hmm. So my theory is that DNet should be fine, right? Like if we're using general purpose allocator and we drop it out of scope, it should be okay. Uh, and let me just make sure that this is failing where I think it is. Invalid free. On the buff D init. Why is that an invalid free? I'm not doing like a double free, right? I wonder if let's think about this for a second. How is we're dereferencing the pointer here, right? So we're taking the buffer from the index to the index plus length at comp time for the given field, which the fields are this. Nope, not these fields, these fields. And dereferencing those, or getting the value of the pointers. Okay, let's try something. Let's just not. Yeah, same thing. I was wondering. My thought was like, oh, maybe we're not getting the underlying value correctly. And then what was happening was like it was actually just a reference, and then when we tried to copy the reference, it like wasn't there. But if we never add the atom, then that shouldn't be a problem, right? Because we're never really setting it, and when we free it at the end, that should be fine. Oh, that was even the wrong. Okay, that was the wrong part. We need to do it here. Yep, same thing. Yeah, so let's just leave it off. And then yeah, I think we do need it though. So we are getting to the done point, which is here. So we are actually finishing the run. It just can't deallocate it for some reason. Man, what is going on here? Root main, pause call, yep. Too far. Hold on. There we go. That's what it was. It's using its it's type it's what is it? The type safety config.safety. Yeah, it's runtime safety checks, which we probably want to look into why that is running. Um, yeah, interesting. So I'm leaking memory somewhere, right? Arguably. Let's see if Valgrind works. All blocks are freed. I take that with a. So my question, has anyone ever gotten? This doesn't make sense to me. I should at least allocate once, right? If I'm using an array list, I should at least get a single allocation. Do I? Am I about to build Valgrind from source for this? Let's see. Yeah. Sort of like a. Oh yeah. So maybe I need a newer version of Valgrind. Let's look at Nix. Yeah. Nope. Home manager not found. Did I accidentally garbage collect home manager away? Yeah, I opened up my I got an error on my computer yesterday. It was like, "Hey man, you're running out of space," and I was like, "Whatever." And then I ran it, and I was like, "Why is my Nix store taking up 100 gigabytes? What's going on here?" Just there we go. All right, cool. You just need to get into your workflow. Uh, let's see. What do you mean by that, Alcius? Just using it in my day to day and projects and such. Nix or what specifically? Nothing. Oh, just. Oh, okay. Yeah, just is cool. Just is really neat. I like it. I like it quite a bit better than make. It was kind of sad though. I was using it in a project for something I was working on, and I was like, I can't. I had to hand off the code to someone else. I was like, I can't do this because I have other things. Like I need to this. Like other people need to be able to work on this. So I was like sad. Well, never mind. Okay, so basically something's going on here. This won't compile if we just do a zig run. Let's see if Valgrind can catch that though. Zig run. It's doing something. Oh, that was the compilation. So this is actually the run. It's been so long since I've actually used Valgrind. Like, it's been a long time. Yeah, it's not something I really think about with Go. I don't know why that is. Maybe that's a bad thing, honestly. Um, but that is something that I'm like, it's fine. It's fine. But yes, I need to get Nix in there too. Once I got to Flakes, I had to stop because I couldn't wrap my hand around it, and had too many other things going on. You know, if you want to do a Flake stream, we can do it. I like Flakes, and they're not as hard as you think. I will say that. Oh, now it's what, is it stuck in a loop or something? Oh no. Okay. All right, so let's do a Zig build. I'm curious. So if we do like a Zig build exe really safe, I would imagine this would probably fail. Yep. But if we do a release fast, it actually works. So what do we miss? What do we not get by using release fast? Or by using I need to know where I guess my problem is I don't know where I'm double freeing from. Because I think that's what's going on, is that there's like a double free somewhere. Release fast doesn't give you those allocations. Doesn't give you that runtime safety. So I'm curious about that. Maybe we can just delete those for right now. All right, so then in theory, we should be able to do this. Let's pull out the debug and let's see how fast this thing can go. Blazingly fast. GCC. Yep. Yep. Yeah, that's fine. That's okay. This is going to be faster, I think, but it's going to. Oh, invalid character. Where did that one happen from? Oh, I remember why. Yeah, I can't actually read these yet. Oh, no, never mind. Now I have more problems. Love it. Oh, I already have. This is the one for all the marbles. End of invalid character. What the? Oh. Yeah, we removed that error handling. So now we have to. Yeah, basically, we don't care. Okay. Try catch. Zig. Let's see. Catch. Do a thing. Catch it. Do another thing. Who needs air handling? That's right. We don't need air handling. Yeah, so I guess we'll just do like. Can I do catch break? Oh, yeah, okay. You have to do this thing where you like go. Uh, what was it before? It's like this. There we go. So we'll just do catch break. Dude, I can't catch a break. See what I did there? Huh? Huh? Okay, cool. Whoa. That's significantly worse. Oh man. Oh man. Okay, maybe I was wrong. Maybe this is not the way to do it. Let's hold on. It was just 2 runs. It could have been slow. Let's amp it up. Let's do like 100 runs. Yeah, yep, yeah, yeah. Hold on. Hold on. Oh no, that's so slow. Oh my goodness. What's this memory usage looking like? Is it climbing in memory usage? Nope. No, that's good. It's just slow. Okay. Well, hmm. Well, okay. Yep. Yeah. Maybe we do need to provide some sort of switch, Celsius. That might be a better plan. That might be a better idea. Pack it up, boys. We're going home. Yep. Yep. Pretty much. Oh, I thought I had this one. Yeah. Oh, that's tough. Hold on. I'm curious. So that's. I wonder if it's even parsing out the atoms. We can do that here. Like we can do like standard.debug. I might have to look into this a little more. I don't know what I'm missing here. Oh, I have to rebuild it because I'm doing illegal maneuvers here. Is it not printing? Why is it not printing it out? Oh, it totally isn't. Oh, this is the wrong spot. Okay. 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 I'm losing my mind right now. That's okay. That's okay. That's all right. Okay. All right. Let's see. Oh. Okay. So it is parsing, albeit not very fast. I know that's not what it looks like right now, but this is considerably slower. So let me see if I can show you the other thing I was looking at. I'm probably gonna hop here soon. I'm trying to cut it out at 9:30. I was gonna see. I figured I'd raid until I would raid over to Alt F4 when we're done. I think he's going live in like 4 minutes for his stuff with front end masters. So I figured we could take a look. Yeah, this is not gonna work. Yep. See, this one doesn't parse either. So this the Rust equivalent can't do it because it's like, oh, the line's too short. Have a good one. I'll stick around for the raid. Cool, I appreciate it. Thanks for hanging. It was good seeing you this morning. I will be back on Thursday as well, so feel free to come by. Okay, so the long and the short of it is we need to figure out because like, man, because we can totally parse this if we do it with. Um, so I'm curious now. let's try, because we were getting that weird error with the, let's do a heap. No, let's not do the heap reader. Let's do array list stream out stream reader. Yeah. Okay, so let's do a release safe and let's see. That should compile. Let's see if we still get the same segfault though. Yeah, see how much slower that is though? I guess it's all those checks it has to do, like on the memory side, but it's significantly slower when we use an array list. I really wish people would just adhere to the spec and I could just read my 80 characters. I know that chopping off the 4 characters that you don't need saves you a lot of space on file size. But we could get better performance if you could just give me 80 characters, people. I'm not mad. I'm not disappointed. I'm not frustrated at all. Yeah, this is abysmal performance. I can tell you right now that the Python variant of this is much faster. Yep. Yeah, the Python variant does a lot better. Yeah, we can bench that in a second too. Yeah, that's awful. That's quite bad actually. All right, let's try it with the other one. So we have one more, which is the buffered stream reader. So this is a non-array list one. Let's try it with release safe. I wonder if that'll. I know we can do it with release fast as well, but I'm curious. Yeah, that's okay. Let's see. So this is my concern: is that if we do it like this, it's just significantly slower. Yep. It's just too slow to use the stream. Hmm. I just don't know. Let's see. I'm curious. Nope. Yeah, this is pretty bad. It's interesting once we switch over to using it. It's just like how much immediate degradation you get when you don't get to just parse it like that. You know? Yeah, that's bad. Hmm. All right, we might have to rethink this. I just don't know where else to go from here. So, yeah, man. Hmm. All right. Well, I think with that in mind, I think I am gonna get going. Um, those of you guys who don't know, the Alt F4 stream is doing a DevOps course at Front End Masters today, which is what I was trying to kind of stream to. Doesn't look like they're live yet. Um, but yeah, um, we'll have to take a look at that as we. I would recommend if you guys want to go check them out, to totally go check them out. I'm gonna get going. Um, let's see. Anything else? All right. So let's see who do we want to raid today, chat? We have options. Let's see. Is anybody gonna dox myself here? No, I don't think so. Oh, whoa. Um, let's do toggle bed actually. See. Oh, he's playing Cyberpunk today. Could do toggle bit or Prime. Does anyone have any preferences? Let's do. All right. Thanks, chat. It was good talking with you, and catch you guys on Thursday. Take it easy.